Hey guys, welcome to Unit 3, which is all about quadratics continue. So for 3.1 is called the zero property law, or sometimes you might see it as the zero product law. Same exact thing. So our objective today is that students will be able to use the zero property law to solve quadratics. So first thing we need to know is, what is the zero property law? The zero property law says if the product of any multiple factors is equal to zero, then at least one of those factors must equal to zero. Keyword, at least one. The zero product property can be used to find where the quadratic crosses the x-axis, which is what we call the x-intercept. So let's see a few examples how this works. Example 1. Remember, this is when I factor a quadratic, I will have something that looks like that at the end. So all the zero property law says is I want to solve these. So I have two factors, which are x plus 7 equals to 0. This is addition. Or I have x minus 3 equals to 0. And from here, these are simple one-step equation where I minus 7 do the inverse operation. 7 are cancel, x is equal to negative 7, which is one of my answer, and in here I would add 3 on both sides. This is cancel, x is equal to 3. So this is telling me if I was to graph this quadratic into a calculator, I will see at x equals negative 7 and x equals to positive 3, those are where the graph crosses the x-axis. Let's look at B. Again, I have 2x minus 5 equals to 0, and I have x minus 4 equals to 0. Okay? So simple. This is a two-step. Add 5 on both sides. This is cancel. 2x is equal to 5. Get x by itself. I do the inverse, which is divide by 2. X is equal to 5 over 2. That's one of my answer. Here is a one step, add 4 on both sides, x is equal to positive 4. So what you're going to do, guys, is pause this video. Yes, Miss Amaru says pause the video, and I want you to try this one on your own, okay? Give it like less than a minute. Pause it, and then tell me what you got. So now you got a chance to try this. I wanted to point out something. You should have gotten x equals to negative 2 over 3 and x equals to 3 over 4. Now, what about this 4? This 4 that's outside here. That doesn't really have an impact on the answer, and which we're going to answer in our second example. It says the zero product states, remember what it said? It said that at least one factor must be equal to 0. It does not mean that all the factors, at least one of them needs to be equal to 0. So if a factor is a constant, then it has no effect on the solution. The reason why one of these factor needs to be a 0 is because when I multiply by 0, I will get 0. So the zero product law can be used to solve any quadratic equation that's factorable, meaning it's not prime, and it will give me something that looks like this in the end, which we did in Unit 2. Now let's see how this works. Solve each of the following quadratic equation using the zero product law. So remember, when we talk about quadratic, I am looking for something that's in the form ax squared plus bx plus c equals 0. The first thing I ask myself for example A is this equation given to me in this form? Since not, I want to move all of these over so I can have something that looks like this. So the first thing I want to do is move the x. So I do add 2x on both sides because I do the inverse. I like to draw my reverse. So I have x squared plus 5x minus 14 is equal to, these cancels off and I'm left with 10. Now I want to get rid of the 10, minus 10 on both sides. My 10 cancel, 0, which is what I'm looking for, looking better. This becomes x squared plus 5x minus 24. Perfect. Now that I have this, I want to say what's my A, what's my B, what's my C. My A is 1, my B is 5, and my C is negative 24. Make my X, because I need to factor these, A times C in the top, which is minus 24, and then my 5 in the bottom. So this is where I'm going to go ahead and think two numbers. When I multiply it, I get negative 24, but when I add them, I get a positive 5. And you will see it works out to be a positive 8 and a minus 3. Excellent. So because A is equal to 1 right here, I know that I can just write these in factor form, which is x plus 8 and x minus 3. But because the question asks us to solve it, I'm going to keep it as equal to 0. Now this is just like we did in the previous example, where I take both of these, x plus 8 equals to 0, and x minus 3 equals to 0, and I solve these. So these are simple one step. I'll get x equals to minus 8, and x is equal to positive 3. So all that means is if I was to graph this quadratic right here, if I was to graph this, these would be the point where it intersects your x-axis. Now let's look at B, which looks a little bit more complicated because I have terms all over. So remember, the key term, and let me just draw a line here so we can do our separate everything, is to get it in this form right in the top here. So I'm going to start by moving the x squared, bring my river, minus x squared on both sides. Remember, I can only combine like terms. These are cancel. I am left with 2x squared plus 12x minus 7 equals to 3x minus 2. Let's get rid of the 3x, minus 3x on both sides. This is cancel. I'm left with 2x squared. 12 take away 3 is 9. Good. 9x, bring down my minus 7. Last thing I'm left with is a minus 2, so I'm going to do the inverse, which is adding 2. These are cancel. I got 0, which looks good like up here. 2x squared plus 9x minus 7 plus 2 will give me a minus 5. Now that my equation, this is going to be my what I'm working with now right here. I have that. I want to say what's my A? My A is 2, my B is 9, and my C is negative 5. Now I want to do my X, negative 10 in the top, and then positive 9 in the bottom. Two numbers, when I multiply it, I get negative 10, but when I add it, I get a positive 9, and those numbers are 10 and negative 1. Good job, guys. So remember, now that A is greater than 1, I just can't do what I did on this side. I have to replace my B term. So I will want to write 2x squared plus 10x minus 1x minus 5 equals 0. I want to replace my B term. Now why do I do this? Remember, A is greater than 2. And then I'm going to factor 2x out. I am left with x plus 5. Good. Here is I'm going to factor out a minus 1. I'm left with x plus 5 equals 0. And then don't forget, they're the same thing, so I rewrite it once, and then I have 2x minus 1 equals to 0. And this is what we see in exercise 1. So all I'm going to do is solve these. So I'm going to do x plus 5 equals to 0, and 2x minus 1 is equal to 0. So, simple one step, minus 5 on both sides. 5 cancel, x is equal to negative 5, which is one of my answer. Here is a two-step, add 1 on both sides. This is cancel. 2x is equal to 1. Divide both sides by 2. 2's are out. X is equal to 1/2. So these are my two x-intercept, or where this quadratic crosses the x-axis. So moving along now. The zero product law is extremely important to finding the zeros or the x-intercept. So example 4, the parabola shown to the right is the equation of y equals x squared minus 2x minus 3. Write the coordinates of the x-intercept on the graph. So all I'm looking for is where on this graph intersects your x-axis. So this is my x-axis, and I'm looking, this is 1 point and this is 1 point. So I know this is my center, so I can see I go one left, so one of my coordinates is at x equals -1, and then my other coordinate is at x equals 1 to +3. And it will always be x equals something. So we can check if these two answers are actually correct, and that's what we're going to do in B. How do we find this algebraically? So algebraically, all it means is similar to what we did in the previous example. So I want to take x squared minus 2x minus 3 and make it equal to 0. And again, this is a quadratic, so I need to factor it. My a is 1, b is -2, c is -3. Factor this out, I get -3 on the top and -2 on the bottom. So I want to find two numbers. When I multiply it, I get -3, and when I add it, I get -2. Those numbers are -3 and 1. Since a is equal to 1, I can just write these factors out. X minus 3 and x plus 1 equals to 0. Once I write these out, I can go ahead and solve them. X minus 3 equals to 0, and x plus 1 equals to 0. Add 3 on both sides. X is equal to 3, which is what we have up here. Minus 1 on both sides. This is cancel. X is equal to -1, which is our answer up here. And again, these points coordinate to these right here. And here's our last 3 examples for today's lesson. Alrighty, so the first example, if you look at it, there is no b term. So this will be a difference of square, where I want to rewrite this with everything having a square. We know 1 square is the same as 1. So this is called a difference of square. So remember, with the difference of square, all I'm going to write is 2x minus 1 and 2x plus 1. And again, we're finding the x-intercept, so we make this equal to 0. Making this equal to 0, I want to solve this. I have 2x minus 1 equals to 0, or 2x plus 1 equals to 0. 2x is equal to 1, x is equal to 1/2. Or let's solve this out. 2x is equal to -1, x is equal to -1/2. So these are my two answers of our x-intercept, where this quadratic crosses the x-axis. Example 2 says a is equal to 3, b is equal to 13, and then my c is equal to -10. Make my x, I have -30 in the top and 13 in the bottom. Two numbers, when I multiply it, I get -30, and I add it, I get a +13. Those numbers are 15 and -2. Now, because my a is greater than 1, I would have to replace my b term. So I will go ahead and write 3x squared plus 15x minus 2x minus 10. And we're just going to simplify the first two terms and then the last two. So here they have a 3x in common, x plus 5. This has a negative 2 in common, which has left me with x plus 5. Perfect. So these two are same, so I'm going to write those back. And then I take 3x and minus 2 and make those equal to 0, because the question, if you look at the direction, the question says find the x-intercept. So basically I want to know, when is that quadratic equal to 0? So I have x plus 5 equals to 0, or 3x minus 2 equals to 0. This will be x equals minus 5, so that's one of my roots. Here I will have 3x, why am I rewriting the problem? 3x is equal to 2, x is equal to 2 over 3, and this is my other x-intercept. So we have one more question to go, which is C. I'm just going to bring that down in the bottom. Y equals 5x squared minus 10x, just so we have some space. Let's write C here. Y equals, what was it? 5x squared minus 10x. So what do we want to do? We want to find a y-intercept. So if I look at this, the first thing I know is that they have something in common. So let's take a look. So both of these have a 5x in common, which I'm going to take out. So I have 5x. What's left over? X minus 2. And I know to find the x-intercept, I have to find when is this equal to 0. So now I have two cases. I have 5x is equal to 0, or x minus 2 is equal to 0. If I go ahead and solve this, I would get divide by 5 on both sides. X is equal to 0. This is one of my x-intercept. Here I'm going to add 2 on both sides. X is equal to 2. And that's my other x-intercept. Alrighty guys, there you go. You know what to do. Good luck.